Welcome to The Explainer. All right, today we're tackling a huge cosmic mystery, one that really gets to the heart of, well, everything. How old is our universe actually?
You know, for decades, the official story has seemed pretty solid. There's this one number you've probably heard a million times. But now, some really strange new clues, found way out in the deepest parts of space, are starting to challenge everything we thought we knew.
And really, this is the heart of the puzzle. Astronomers have found stuff out there, like this star they call the Methuselah star, which is a great name for it, that looks older than the Big Bang itself. I mean, that just shouldn't be possible, right? It's kind of like finding a baby picture of your grandma that was somehow taken before she was even born. So, what gives? How do we even begin to solve that?
Okay, so to really get our heads around this contradiction, we've got to first understand the established timeline. Let's call it the universe's official story, the one told by our standard model of cosmology. And this is the number. For years, this has been the absolute bedrock of cosmology. Our standard model, which has this fancy name Lambda CDM, has confidently told us this is it. This is the age. And they get this number by watching the universe expand and then just winding the clock backward.
So how do they do that exactly? Well, scientists trace that expansion all the way back to the very beginning, to that super hot, super dense state. The model points to these really key moments, like Big Bang nucleosynthesis. That's when the first light elements were cooked up in just the first 20 minutes or so. And then there's recombination, which happened way later, about 377,000 years in, when the universe finally cooled down enough to become transparent.
Now, one of the biggest pieces of evidence for this whole thing is something called redshift. The idea is, as galaxies are flying away from us, the light they give off gets stretched out. And that stretching shifts the light toward the red end of the spectrum. The analogy everyone uses is perfect. It's just like the sound of an ambulance siren changing pitch as it drives away from you. Same idea, but for light.
This standard model also gives us a kind of recipe for the universe. And let me tell you, it's a weird one. You see, all the stuff we can actually touch and see, you know, stars, planets, you and me, that's less than 5% of everything. Yeah, just 5%. The rest? It's made of this mysterious dark matter and an even more mysterious dark energy, which is the stuff that's actually making the universe expand faster and faster.
So as tidy as that picture sounds, it turns out it's not perfect. Lately, with these incredibly powerful new telescopes, we've started finding things that, well, they just don't fit. They're creating some serious cracks in our cosmic understanding. And it's not just the Methuselah star. The James Webb Space Telescope has been peering back to the dawn of time, and it's spotting galaxies from just a few 100 million years after the Big Bang. So what's the problem? Well, these galaxies are huge and look surprisingly mature. They look like they should have taken billions of years to get that big and complex, not just a few million.
All of this has created a huge cosmic puzzle, and it's led to a really bold new theory, one that actually dusts off some old ideas and uses them to propose a radically different age for our universe.
So, to try and solve this, a physicist named Rajendra Gupta has come up with what he calls a hybrid model. It's fascinating. It takes the expanding universe that we all know and combines it with two other ideas, and yeah, they're pretty controversial.
Okay, so the first part of this is something called the tired light theory. It's actually an old idea, but the suggestion is this. Maybe not all of that redshift we see is because of expansion. What if photons of light just lose energy? You know, they get tired as they travel on these incredible journeys across billions and billions of light years.
The second idea is, wow, it's even more mind-bending, to be honest. It's the idea that the fundamental constants of physics, you know, the basic rules that tell particles how to behave, might not actually be constant. What if they change over time? If they evolved, that could stretch out the time it took for those early galaxies to form from just a few 100 million years to maybe several billion. And that would totally explain why they look so mature.
So here's the really important takeaway. Gupta's model doesn't just toss out the expanding universe, not at all. Instead, it suggests that the redshift we're seeing is a mix of two things. The universe is expanding and light gets tired. It's a hybrid explanation for everything we're observing out there.
And the result of this hybrid model? Get this. If it's right, the universe isn't 13.8 billion years old, it's actually 26.7 billion years old. That's almost double the age we've been working with. And of course, that much longer timeline would give those ancient stars and galaxies all the time in the world to form and grow.